lines in space 3D. As you know that we are doing 3D, so now you'll see different formulas to find the lines and in Cartesian form and in vector form. So lines in space means lines in 3D. Because in 3D you will see there are different possibilities which are not in 2D. So first of all, our first type of line that we are going to discuss is equation of a line. Equation of a line passing through a given point. How to write this equation? Passing in 3D, passing through a given point and parallel to a given vector and parallel to a given vector. Ubaid is waiting in the room. Okay. No one is in the room. No one is there. Tell him to join again. Maybe I'm not having anyone in the room. So maybe he removed. So tell him to join again. So equation of a line through a given point and parallel to a given vector. Parallel to a given vector. Parallel to a given vector. Okay. So we have x-axis, y-axis, and z-axis. 3 axes, as you know that we have to draw the 3 axes. X-axis, y-axis, and z-axis. Or you can take this x-axis, okay, and this one is your y-axis, and this one is your z-axis. Now the condition is a line passing through a given point. So suppose the line is in 3D. Just you remember that we are doing 3D. This is a line passing through a point. So that point is P, that or A. Take A because P we will take for general point. This is a point A from which this line is passing, and this line is parallel to any vector, given vector. So this is parallel to some vector that can be Suppose this is parallel, huh? Yes, this is a parallel vector. Hmm. This vector is given as vector B, and this point is having its coordinates, suppose x1, y1, and z1. So this way we will write every equation in terms of vector and in terms of Cartesian coordinate system. So every line will have some point. We can assume always a some point P whose coordinates are x, y, and z, because we have to write the equation in x, y, z. So then we have the from here to A. This is what? This is the position vector of point A. We are writing in terms of vectors first, and later on we will write in terms of Cartesian coordinate. How to write in Cartesian coordinates? So this is okay. Wait, came now. This is the point which will join point P. Suppose this is a point P. Okay. So this is the position vector of any point P on the line. This is a line. You can extend it. So what will be the equation of this line? I think you understood that the condition we have to write the equation of a line. We can take suppose RS. We have to line the equation of RS, and it is parallel to this line UV, whose vector is given, and there is a point given in on this line also. Okay. So what will be the equation of this line? I will show here. Huh? So equation of a line passing through a given point and parallel to a given vector. So its equation will be equal to vector R is equal to lambda times vector B. Lambda times vector B. This is the vector form. This is the equation of a line in vector form when the line is passing through a point A and parallel to a given vector. Okay. Now, how to write in the Cartesian form? In Cartesian form, always write in the vector form and then convert into Cartesian form. In Cartesian form, vector R is a general vector. It is always equal to xi plus yj plus zk. Okay. Yes, Sharik. What is the difference between vector and Cartesian form? Good. When we are writing, see this equation in Cartesian form, when we are considering the x-axis, y-axis, z-axis, Cartesian coordinate system. Cartesian coordinate system means if you are, suppose you have a point here, so it can have three coordinates, y-axis, x-axis, and z-axis. So it will be represented by three coordinates. So whenever we are writing any equation in terms of x-axis, y-axis, and z-axis. Means when we are writing in terms of component form, so you can say if it is converted into the component forms and ijk will be removed, means there will be no vector. Without vector, or you can say in forms of x1, y1, z1, x, y, z, Cartesian coordinate, means where the point is represented by the position of x, y, and z axis. So in terms of that one, if we are writing, that is called Cartesian coordinate system and Cartesian form. Like Cartesian 2D coordinate system, x-axis, y-axis, we are having 2-point line passing through 2 point y minus y1 is equal to y2 minus y1, x2 minus x1, x minus x1, that we did in 2D. Similarly, in 3D, if we are writing in x, y, z, any equation represented in x, y, and z, there is no vector, then it is called Cartesian coordinate system. And Cartesian coordinate system, OP is a general vector. Any point P, we should take any point on a line to write its equation. In 2D also you are doing the same. So always that R is represented R is the position vector of any point. This is vector R, okay, and this is we are denoting by vector A. Actually this is vector A. So vector A, OA is equal to vector A. So equation of a line will be equal to, A will also come, sorry, this A plus, here the equation will be vector A plus lambda times vector B. Vector A plus lambda times vector B. A will be 0 when the line will pass through the origin. So R is always xi plus yj plus zk. R is the position vector of any point on the line. And vector A, let us suppose that vector A is here actually the points, we are denoting the points of A, x1, y1, z1. So when we resolve vector A in components, so it will become x1i, correct, plus y1j plus z1k. This is vector A, and vector B also, it can be reduced into the components, and we denote this vector B as b1i plus b2j plus b3k, b2j plus b3k cap. So B vector is b1 a1 okay. A1, take A1, A2, A3 instead of x1, y1, z1. Here we should take the coordinates of the point A as A1, A2, A3, not x1, y1, z1. This takes A1, B1, and C1. So A will be denoted by A1, 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 A2, and A3. A1, A2, and A3. Just okay. Listen again. 1 minute. Let me. This vector A has coordinates as let's remove this point, huh? Okay. So this is A, and the coordinates of A take as A1, A2, and A3. Instead of X, Y, Z, you take A1, A2, A3. Then this will change to A1, A2, and A3, and B1, B2, B3. B1 I plus B2 J plus B3 K. Okay, see again. This is a line passing through the point A whose coordinates are supposed to be A1, A2 and A3. Because generally if A is a point, we will take A1, A2, A3. And B is a vector which is parallel to this line whose equation has to be written, that is Rs. So R, vector R will be equal to vector A plus lambda vector B in the vector form. In the question, generally they are asking write the equation in vector form, write the equation in Cartesian form. But generally, what they are doing, they are asking in in both the forms, asking in both the forms, right? In Cartesian as well as in vector form also. So you are suggested to write in the vector form first and then convert into Cartesian form. We are doing that one. Huh? So now I think you understood this point. A, coordinates of point A, A1, A2, A3, and therefore the vector A will be A1, I, A2, J, A3, K, and B will be this one. Now this you can substitute in equation number 1 to convert into the Cartesian coordinate system. Put in first. When you put in first, vector R, instead of vector R, you will write xi left side plus yj plus zk. And right hand side is A1 I plus A2j plus A3k. This is the value of vector A. Yes, we are substituting the values of vector. Plus lambda times vector B. And vector B is B1I plus B2j B1I plus B2j plus B3k. Like this, you can directly put the values if the point coordinates of the points are given and vector B is given in the Cartesian coordinate system, and then solve it. Now how to write, how to solve the equation? Now you can equate x I, left side is xi plus yj plus zk. Ijk should be removed because we are going to write in terms of, now I, if you will take I common from these two terms, it will become A1 plus lambda B1 I plus j common A2 plus lambda B2 j plus A3 plus lambda B3k. Now you can equate the coefficient, comparing the coefficients of ijk, comparing the coefficients of ijk, comparing coefficients of I, j and k. So we get x is equal to A1 plus lambda B1 and y is equal to, you get y is equal to A2 plus lambda B2 and z is equal to A3 plus lambda B3. Okay. Now, if you will find the value of lambda from first equation, it will become x minus A1 upon B 1 is equal to lambda, correct? From second equation, we will get y minus a2 divided by b2 is also the value of lambda, and z minus a3 upon b3 is equal to lambda. So all these values are the values of lambda, so that we can equate. Now we can write in the Cartesian form. Therefore, this concludes that we can write x minus a1 upon b1 is equal to y minus a2 upon b2 is equal to z minus a3 upon b3. In 3D, we are writing the equation of a line in this format, not is equal to x and y, because it is 3D, so we will write in this form. So this is the equation of a line in the Cartesian form passing through a point and parallel to a given vector. Okay, so this is the Cartesian form, equation of a line. This is the equation of a line passing through P point whose coordinates are a1, a2, a3, a1, a2 and a3, and parallel to a vector b, and parallel to a vector b, which is resolved into the components b1i plus b2j plus b3k. So equation of line can be written like this. Now second step, we will see how to write the Cartesian equation. This is the Cartesian equation. This is what? This is the Cartesian equation. Why it is called Cartesian equation? It is in x, y and z only. There is no vector, so this is called the Cartesian equation. This is called the Cartesian equation of a line. So we should write here not equation, we should mention it as Cartesian equation of a line. So Cartesian equation of a line through one point parallel to a given vector. In this condition, we can write like this. So that means Cartesian. One more thing, if any point we have to write any point on this line, we can find the value of x, y, and z. If you will find similarly from these three values, try to understand my point. If any point on the line, we have to find any point on the line. So this one, we need too much time to study 3D. So if you will find value of x, x will become b1 lambda plus a1. Okay, and y will become b2 lambda plus a2, and z will become b3 lambda plus a3. Okay, so that means we can write any point on the line. Any point on this line can be represented by any point on this line is xyz, that is equal to, we can say xyz because we have taken the xyz point, and that is equal to here b1 lambda plus a1 x coordinate, b2 lambda plus a2 will give you the y coordinate, and b3 lambda plus a3 will give you the z coordinate. So three coordinates we can find out or any point which lies on this line. Can you rejoin after some time? 10 minutes left.